So, quad this is week 67 of the Perl Weekly Challenge. Let's dive right in. Using Dyalog APL. I'm going to be honest, I had a little quick peek at this week's problems. Hopefully, I think they might be quite straightforward. So, let's start with number combinations. You are given two integers, m and n, scalar integers. Write a script to print all possible combinations of n numbers from the list 1, 2, 3 to m. So say we had m and n, we can put m as alpha, n as omega maybe. So 1 to m is iota alpha, or iota m. Only sorted combinations, we can work that out after. And it's n numbers, so it's combinations of length. Oh, we did this kind of last week, 2 weeks ago, right? So if we catenate all the numbers with themselves, make sure it's to the power of -1 plus omega. Alright. Alright. So if it was 3, then it does it twice, of course, the selfie is a curse. Thought this would happen. So it's iota alpha dot comma. Right tack. And we start with iota alpha, but we can perform the catenations -1 plus omega times. Okay, these are all our 3-digit combinations. If we look at the first lot, these are all our 1s, so we can keep them as is. And if we ravel, then it's sort of just one big long list. Might be a better way to do this, because this approach is going to involve filtering out all of these things, all the ones which aren't in order. So we could write a function to see if a combination, and we don't want one with itself, right? So if we had 1, 1, that's not valid, 3, 2 is not valid, but 2, 3 is valid, okay? And we just want this function to return 1 if it's a valid sorted number combination, and 0 otherwise. So if we mix this so we can do grade up rank 1, then the ones that are valid will be 1, 2. So this is iota, length, omega, match, the grade. Oh, sorry, not length, omega. There we go. Don't know if this is the best way to tell if it's sorted. Like another approach might be to literally use a sorting idiom. Like so, and see if it matches omega itself. Do that on each. 1, 1, 3, 2, 2, 3. Oh, haha, of course. These are all inside the same function. Yeah, so this is another approach. We can, for giggles, have a look and see if there's difference in performance. I'm expecting the idiom to be quicker. Yep. And I guess, and it's more idiomatic, right? You're asking, is it sorted? Oh, and also this thing here. We'll apply each instead. I'm doing some mixing and other stuff. So this, each. Try again. Anywho, we'll go with the sorting looking one, and then we also want them not to be the same numbers repeated. So that's basically, does the unique match the original? Omega. both of these, and we can see that only the third one's valid. So this will tell us which ones are valid from our old, this guy here, our first sort of bit of code. Generate all the combinations. These are our combinations C filtered by the valid ones. 1, 2, 3, 1, 2, 4, 1, 2, 5. Yep. And 2. 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. So this works. Number combinations. If I feel like it at the end, I might revisit this. Just to see if there's a better way of only generating increasing values. Let me have a little quick think before I move on. So in our example with 5 and 2, we have only got combinations of 1, 2, 3, 4 because 5, 5 isn't valid. So we can take these numbers and then combine them or catenate with each of 2, 3, 4, 5, 3, 4, 5, 4, 5, and then 5. So is there a way of generating that? 2, 3, 4, 5, 3, 4, 5, 4, 5, and 5. Omega minus alpha is, alpha minus omega is 3. 2, 3, 4, 5. We want 4 numbers, and it's omega plus that gives us the, 2, 3, 4, 5. I think I'm aware of something that might help, but I can't remember how to do it. There are 10 combinations. Is this coincidence or is this correct? Let's see. Factorial 7 is 21. Yep, okay. There's some kind of choose and choose thing. So we can work out how many we want and then modify the values. 5 and 2, there's 10. Reshape iota neg1 plus iota alpha. Whoa, iota alpha. Neg1 plus alpha. Yeah, okay, never mind. And omega choose alpha, reshape this. This is the correct number of numbers. 4, 5, well, that's not quite right. Yeah, this won't quite get us where we want to be. Alpha, reshape, enclose. Get all of these. And then if we take, we call this A, and then we do A is greater than each. Oh, sorry, no. Because the shape of A should be the same. Oh no, because that's 5 of them, whereas there's only 4. How many runs do we get? 1, 2, 3, 4. 4 runs. A1 plus alpha. There we go. Then we can do A. It's greater than each of these. Is that right? That's not right too. Because there's our 1, 2, 3, 4, 2, 3, 4, 3, 4, 4, and we'll add 1 at the end. Is less than equal to B times 1 plus b times member. Remove the zeros. Add 1. And then it's a comma each. Oh no, don't want to list yet. Not quite. There we have it. This one is maybe a little uglier and less idiomatic, maybe. I mean, I didn't think of it first, so there's some argument that it's not as intuitive, but I expect it to be faster. Oh. Okay, so once again, let's do our runtime comparison. I expect the new one to be faster because we're generating less data. Yep, and it's reasonably significant. So I guess what I might do is just put them both in. I don't know. So let's move on. Letterphone. This is closely related to one of the recent APL problem-solving competition problems. I say recent, maybe 2 years ago, if not last year. Digit string S, which we will have in APL as a character vector. Print all possible letter combinations that the digit string could represent. And a pretty nifty way of doing this is basically, and it's only letters. He hasn't put a 1 there, but I guess this is the mode we're going off of. So a 1 could be an underscore, comma, or an at symbol apparently on this keypad. So I guess we'll go with that. So start with 1, underscore, comma, at, 2, ABC. Okay, let's pretend that we can only use the first 3 just to make it simple to start with. And our string of numbers, in this case, let's do 23. 32 just to spice it up. So alpha index of omega, it's not found in there. Maybe another approach is to say 1, 2, 3, and then all of my other ones. 1, 2, 3 is the first one, and then another. So character vector of all of the numbers, which actually quad D we can do, apart from 0. So are we ignoring 0? I think so. And then nested vector of character vectors for each of those. Start with the first 3. So the digits, which is the first of alpha, index of omega. So, of course, dingus. Yeah, okay, even easier. We just want the letters, nested vector of character vectors for these. Omega, execute each, and index into alpha. And outer product catenate reduce? Potentially. This solution has 9. Any 2-digit thing, if there's 3 in each, should have 9. I think one thing are we missing? Is there a CF? No. Okay. I think we're there. So alright, let's just keep going then. GHI, JKL, MNO, PQRS, that probably should still work. TUV and WXY, and Z. We just have some extra combinations in that case. Should get the same solution. Let's name it. Let's name this thing first, because it's just difficult to see. And when we make this a multi-line function, we can embed chars inside as a default left argument. So that would be our solution. So both of these problems this week are kind of these combinatorics things. Yeah, and since they're combinations problems, obviously my first instinct is to go for an outer product. In the first case, it turns out we could get a more efficient implementation by considering what the parameters are. In this version, all the combinations is exactly what you want. It literally says all possible combinations. The last thing I'm going to do then is sort of go into my text editor and comment stuff. So letterphone, start with our default alpha of chars. Oh yeah, I found out where repobj is. quadse.dialog.utils.repobj chars will give me the expression I need to generate that array. Ravel disclose outer product catenate reduction alpha indexed by numeric omega. So letterphone 3.5. Here are all of our combinations. What is there to say? I guess it's just the character vector of digits, for example 3.5, and we return all possible letter combinations from a keypad defined by alpha. And this one, we've got the two versions, which I guess because it's like a coding challenge, I feel like we can keep both. The description this time is all strictly ascending vectors of length omega, which contain numbers in iota alpha. Or I guess numbers in elements of all combinations of iota alpha, digits in iota alpha of length omega, sorted and unique combinations, strictly ascending combinations, integers. What do I need to write that? Because that's what it says. If you read APL, it's integers up to neg1 plus alpha. Maximal run repeated neg1 plus alpha times. Remove zeros and add 1. Catenate A's with C's. We'll go with that. Yeah, this week is sort of a real APL boon week, right? Combinations of things. It's just such an array-oriented thing to do. Yeah, so first attempts were both outer products, which is the go-to APL thing. Jot.f doing combinations of alpha with omega, apply some function between all the combinations. In this case, catenating. And then we also found a more efficient way to do the number combinations by only generating the ones we actually wanted. Awesome. Once again, thank you very much for watching. See you next time.